just a little bit about our centre. We're the Centre for Circular Design, and it only launched in August of this year. We're a practice-based community of designers based at the University of the Arts London, and it's got a little bit of a longer history than just a few months. It started as something called TED, Textile Environment Design, back in 1996 with a group of tutors from the textile courses at Chelsea College of Art, and we turned 20 last year, but we decided that we no longer wanted to compete with the other TED and felt we needed more of a branding refocus, and so this year we were confirmed as a official research centre in the university. This is the team. We have sort of 3 permanent members of staff, an emeritus professor, Kay Politovich, and my co-director, Professor Rebecca Early, a group of postdoc researchers working on specific projects, an expanding group of PhD researchers. Clara Vuletic just got her PhD confirmed this week, and also sort of research assistants that really support the work. So the work I'm going to show you today is by no means only mine. It's all very, very collaborative. As I said, this group started back in 1996, and it really came about directly from practice-based textile designers. I don't think really we called ourselves academic researchers at that point. Quite a few of us came from industry, ran our own businesses, certainly were involved on the teaching. But we were fascinated by this idea that design had a role to play in environmental improvements. And there was a paper that came out at this time talking about the decisions the designer making having this sort of very high level of impact on the outcome. And we just wanted to understand initially how that could be, how we could really change our design process to create products differently. So what you'll see today is very much based on making. That still continues today as our key methodology. Just to outline a little bit, I suppose, about circular design. We're at this moment now where it's kind of exploded. And a recent report from the Ellen MacArthur Foundation, who are really the ones responsible for driving the expression the circular economy, came out with this new report very recently. And we're very clear now on sort of what the problems are in terms of the textile industry. We realise that, the amount of fibres that come into the system as virgin feedstock and get used and then end up either in landfill or incinerated is still way too high. And for all the kind of technological advances, this still seems to be the case. And they've also outlined some very sort of plausible solutions. There are some aims and objectives that we really need to aim for. We need to increase our use of clothing and textiles in terms of longevity. We need to radically improve recycling, make better use of resources and renewable inputs, and phase out harmful substrates. Okay, that's all really clear. What isn't so clear is how that impacts on the design process, and that's what most of our research projects are looking at. I think really the positive aspect, or the thing that's different about circular design and sustainability, in my view, is a kind of a logic, a kind of a bringing together of different stakeholders, different parts of the cycle, towards a common effect. I think with sustainability, there are so many different approaches, different priorities, different viewpoints on what it actually means. But there's something about circular design that seems to be pulling people together in a really effective way. And I still think possibly one of the most interesting projects in this area was something from the RSA a few years ago called the Great Recovery, which tried to map out exactly what these activities might be and how you could design in a circular way. So you can, if you stick with the user phase, you can, how can we design to make products last longer? And it's not just about physical durability, it's about how do we get people to engage. If you design for service, how do we engage with the new business models, the sharing economy, different models for products to flow around the system. Designing for reuse in manufacture is perhaps where most of the traditional materials recycling might stay. And then material recovery. This is the area that's really exploded over the last few years. How can we get materials and take them back through chemical processes, right back to the virgin quality material? And there are many, many projects now getting very close to success in this area, which I'll talk about later. So in all of these activities, there's a role for design. But the reality is that for all the neat and tidy circular schemes that we see, I think it tends to look a bit more like this. It's a very complex network. There are very few material cycles where the inputs and outputs are exactly equal. There's always some loss on the way into a system, some loss on the way out. The products don't get recycled back into the products they were. They might go downstream into a different system. And that's okay, because I don't think nature does that either. We have to get better at reusing the base materials. And of course, it's not just even material systems. We're talking about, this was the sort of the final result of the first phase of our MISTRA Future Fashion project, where we tried to understand the different systems and how they intersect. So, of course, we have material systems, and as designers, we get very involved in those, and we can design better products to flow through and be recreated. But also, we're talking about social and business models and how they interact. And we're also, a group within our research centre are looking more at designing to change the self and mindsets. There's a whole sort of piece of work around human behaviour and how that needs to be brought on board at the same time as making these material changes. So then we start to become really interested in where these things intersect. It's very, very rarely that we find one of our projects sits within one space. It's all about connectedness. So product and society, society and self, self and product, and they all come with different challenges. So in order to change behaviour, we need to understand what the material systems are that lead to good. This is one of my kind of frustrations in a way with the world of sustainability. There are quite a few organisations and people out there telling us we need to change, but very, very few who can convincingly explain to us exactly why and how. And I think we need a lot more understanding on that level. In order to transform industry, we need to develop business and material systems in tandem. So it's no good having this fantastic recycling technology that works if there's not enough feedstock to push through to keep the industry going. If the consumers aren't ready for it and don't want it, there's no market for it. So these things all have to happen at the same time. And in order to apply new business models, we need behaviour change for the same reason. So this really was, this is a very sort of short version of the final report for MISTRA, which is available online. And obviously, if we're going to get involved in all of these different systems all at the same time, then we're intersecting with many, many different stakeholders and groups. In a way, when I first started working as a textile designer, I actually didn't even work on fabric. I worked on paper. It was a graphic exercise, and the paper designs got sold and they got produced as fabric somewhere else. If I was lucky, I saw where they ended up. I think we've moved into a completely different industry context now, where the collaboration between these different groups and our understanding of materials as designers becomes more and more important. So I'll talk a bit about how we're able to sort of collaborate with these different groups, whether it's policymakers, resource management, materials experts, manufacturers, brands and companies, and really importantly, consumers or users. So I think we've got sort of 3 steps or 3 challenges if we're going to get anywhere near a circular future. And those 3 challenges are all around systems thinking. I think we were talking yesterday a little bit about design thinking, and I feel like this sort of area is progressing into a more developed and systemic part of design practice. So we need to understand the system. And to do that, we need to understand all of the systems, materials, models, and mindsets if we're going to design a product effectively. We need to then redesign the system. And to do that, we need to work with all of these collaborative stakeholders and find new tools for collaborating with them. It's not always an easy or comfortable journey. And we need to then change the system. I mean, we're considered in our university as very much at the applied end of research. But I think with something like sustainability, circular economy, it doesn't work just sitting in theory. You have to be testing these ideas out in industry in order to make change. So I've sort of put together a presentation to explore these ideas through projects that have happened in the centre over the last, say, 10 years. And one of the things that we really focus on in our input into the teaching, especially, is this idea of how we understand products as journeys. We don't think anymore about products as being a static, collection of materials. We're really encouraging students to follow the trail back as far as they possibly can and to understand where materials come from. Quite often designers get the material in their hand at the point when it's already a product, it's already a finished material. And there are so many processes and parts to the journey that happen that once you understand them become very much a part of the brief. So I think the work of Edward Batinsky is absolutely brilliant for this. I don't know if you know of him. He's a photographer who photographs the impacts of extraction, materials extraction really, around the globe. So he goes to oil refineries and quarries and mines, and also spent a long time in production facilities in China. And this is a shot from a film that basically starts at one end of the production line and rolls slowly across it, and it takes about 20 minutes to do so. This view goes on for 20 minutes worth of filming. So it's really, really impactful, and I think for design students especially, it really takes them to a point of understanding about materials. But also, as well as the sort of the raw materials and the production, also what effect we're leaving behind. One of our MA students did a brilliant project looking at kind of the way we might be changing the minerality of the earth, basically, by what we're using and disposing, and did a kind of a conceptual project looking at what we might be mining up in years to come. And so in order to try to communicate some of these materials, we felt we needed some new ways of, I guess, presenting and understanding them, because if you look at material classifications, the traditional scientific models, they don't often give the whole picture. They talk about raw materials and they group them into biomaterials, synthetic materials, minerals, but quite often they're not. They're talking sometimes about processes, sometimes about raw material. So I wanted to understand in a way that could communicate more clearly the difference. So for example, trying to think about materials all as being animal, vegetable and mineral. It's a very old classification. But acknowledging that what we do to those materials is what counts. So for example, with vegetable materials, the most common one would be cotton in textiles, which is a seed fibre, and it's pulled pretty much straight from nature as it is into a fibre. But we can also make a synthetic or a semi-synthetic from the same cellulose through chemical processes. So you can end up at very, very different material outputs depending on the processes. And if we start to understand them, importantly, we start to understand how to undo those processes. So this was a project called Animal, Vegetable, Mineral. It's a website, and it's actually built up of lots of material animations. And the idea is you can go into different material worlds, and there are crossovers. So the material map probably explains it a little more. For example, polyester, which is the most common fibre in textile production, can be made from oil, of course, that's the most common, but it can also be made of corn, and it can also be made from milk. So, and that corn, as well as polyester, can be made into a bioplastic. and the milk can be cheese. I mean, you know, we kind of threw some things in there to just indicate how important the processing is. So this is a very simplified map to show these crossovers in journey, and the next stage will be something more complicated, but it's focusing on the most common textile fibres. And for example, I think I was talking this morning about one of my bugbears, bamboo, which is often presented as the most sustainable fibre. Yes, the agriculture of bamboo is better than cotton, but the bamboo process quite often is a viscose process, which can be a very harmful one. So when you're buying a pair of cotton socks, you're probably buying a synthetic bamboo socks. And I think if designers understand that a little bit more, we can make progress. One of our PhDs as well is using sort of really understanding material systems from a fabric point of view. So we can understand the raw materials, but also how we construct the cloth has huge implications in terms of how we might be able to recycle it. So Letitia's been researching all the different constructions or ways that we blend fibres together, which make them almost impossible to recycle effectively, and by enlarging. So these are sort of gigantic models of textile constructions. And she's using them to have conversations with the recyclers, the recycling industry, and finding some interesting insights around which materials, for example, can be identified by fabric sorters. Quite often, if you've got a complex blend, the recyclers don't know where to put it. And also looking at, for example, which types of materials might be able to be chemically recycled at the end of their life. So this is quite a new PhD project, but it's interesting in terms of, I think in product design, there's a lot of work around designing for disassembly. And products have components and can be disassembled with clever construction. With textiles, it's quite complex because even at the fibre level, you might have a blend. You might have it at the yarn level, you might have it at the material level, you might then have a finishing coating on top of the fabric. And all of these different ways of blending materials are really complex and difficult to identify and disassemble at end of life. At the other end of the spectrum, we also have a PhD student a little bit further on, called Miriam Ribble, and she is interested in the chemical regeneration process for cellulose. So she's been working with our partners in Sweden and in Finland in their lab to understand the chemical sort of processes for taking a recycled cotton, or they also do it with cardboard and other fibre cellulose back into a regenerated fibre. So we developed this kind of design researcher in residence method where she goes and spends a block of time in the lab just understanding the processes and the craft, in a way, of the science. Then she goes away and designs her project, and when she returns, she's actually intervening with this science. So for the first project, she was looking at the way they were producing this cellulose and realized that there was an opportunity to code the fibre as it was extruded. One of the real challenges for recyclers is knowing what the fibre is made from and where it came from, and all sorts of layers of information around its production. So she came up with a conceptual part to her project, which was something she called the Recyclopedia, where, you know, this is the point at which you could understand what the coding means, presenting all the data of materials as a visual archive. But then the sort of the real craft part of the project was her creating fibres and materials from the process. And she's continued and repeated that with 3 different labs, 3 different residences, and 3 very different outputs. But it's interesting because that sort of action, I guess it's a little bit like spending time with the user. You know, by spending time with the science, design can sometimes shortcut some of these processes and bring them into the actual product design. And one of the most, I suppose, satisfying things about this was the response of the scientist. We're getting some interesting data around, not that Miriam's going in and teaching the scientists about science, but she's asking different questions and starting different conversations. And one of her longtime collaborators had said that it had kick-started different approaches and different pieces of work from her time spent in the lab. My own PhD, which back in 2012 now, was focused on understanding, I suppose, recycling approaches for designers. So at that point, when I started the PhD in 2005, you know, most recycling activity in textiles was really upcycling. It was end of life, identify a waste stream, use design to transform that waste stream into something that we can reuse. And that still exists today as a strategy, and it can still be very, very productive. But there's an issue. It's you know, it might have one extra life, it might have a couple of extra years of life in it, but what happens is it gets blocked again at the end of life, and there's only so many times you can go through that process. So I think at the time when I started, it was when Teijin had just launched their cradle-to-cradle polyester fibre, where they can depolymerize a polyester back into a virgin fibre. And I wanted to understand how, as a designer, we need to make different decisions in order to fit with that system. And also, there was a sort of a realization that actually nothing is that tidy, and that if you think about nature, even, you know, a tree casting its leaves, which biodegrade into the soil, they don't grow straight back into the tree. They might become something different, but they become the building blocks for other materials. So, you know, how can we move towards a more complex, connected system in the future? I didn't quite get to that bit in my practice. And because it was practice-led, really, I spent a lot of time trying to test these strategies and form the strategies through making. So I was interested in what we needed to do differently with these polyester materials in order to create these closed loops. And the answer was very simple. We had to keep them 100% polyester, as someone helpfully pointed out in one of my early interviews. But the problem with that is everything we do as design involves sort of complexity. If we want to add decoration, we want to add function, we want to add strength to the design. How do we do that if we can only ever use one material? It's not the answer for everything. So I was exploring the use of lasers for finishing at the time, and I came across a particular type of laser that's only used in the medical industry, and it means you can weld together multiple layers without affecting different parts of the surface. So for example, I could have 10 pieces of fabric together and I could weld layer 5 and 6 and not affect the rest. So it was an incredible kind of moment and a tool to explore. So again, I spent this period of kind of design researcher in residence at the lab in Cambridge, and got to know this tool as basically my crafting tool, and ended up with about 20 different finishes that could be replicated without additional material. So if you think all of these samples here are made from the same fibre and they've gone through the same process, but they've ended up with 20 different finishes that normally would need additional materials. So quite simply things like flocking without any glue. The flock is just welded immediately to the surface of the fibre. Transparency caused by changes in the makeup of the polyester. You can make a polyester fabric clear by plasticizing it. 3D effects that were caused when you put different materials together, and almost printing effects as well, using the transparency. So the idea was that you could have a production hub that didn't need to be sent out to multiple places, and that could be efficient and digitally run and mass customized and still recyclable. So the key was that any of these pieces could be put through, at that time, the Teijin process and turned back into virgin quality material. And what was interesting about the process, actually, it was something that occurred to me later when working with a PhD student who was also using the same equipment, was this thing, I suppose, about disciplinarity, actually. So as a printed textile designer, I was going into the lab and I was using print techniques in order to hack this this particular technology. It works with an absorber, so the laser can't see the material, it's invisible to it until you apply an absorber. So I was applying this, this absorber as a print, as a stencil, and then getting different effects through that way. I have to say the scientists in the lab thought it was very peculiar. But my PhD student, Helen Payne, was a constructed textile, a knitwear designer. And she was interested in the effects of stretch and controlling stretch. So she went into the lab with her a totally different set of tools with kind of frames to stretch the material, and she did some really interesting sportswear for Speedo where she could control the body through the control of stretch of the material. So it was, even within the textile disciplines, there was a completely different approach. And this work's continuing now. And then, I suppose once we understand the system, the challenge then is how do we even begin to redesign it? As I touched on earlier, the textile sort of cycle is full of an enormous number of stakeholders in the value chain. And our current project, Trash for Cash, which is an EU-funded 19-partner project looking at what design, well, the overarching theme of the project is something called design-driven material innovation. And we are looking at how design can somehow intervene in the science, in the development of new techniques to chemically recycle. And so we work with scientists based in Finland at Aalto-Chem and VTT, and also at RISE in Sweden. And they're all working on different chemical ways to transform cellulose and polyester. There's about 4 different routes to do that. But of course, once the technology works, the whole cycle has to come together in order to make it work. And also, the materials produced from that recycling have to be of a certain quality and able to be used in high-value products in the market. So the idea was to bring together a consortium to co-design these products together to try and influence the development of the technology. And this is really what the project looks like most of the time. We meet every 2 months, 19 partners, different stakeholders, and we're trying to co-design these materials together. And a lot of it is about relationships, getting to know each other, communicating, language. You know, how we understand each other is really key. And quite often we have to find ways to bring information across in multiple ways to speak to everyone. So the designers like to work in a particular way, the scientists need to work in a different way. How do we bring these people together to co-design? And one of our postdocs has been kind of analysing the process as we go through it. And we started from a very open brief. We ended up with hundreds of sort of initial ideas, but we realised there were certain targets we had to hit in order to make sense of this project. So, you know, we had to consider end of life as the ultimate brief. Everything we designed had to be able to go back through the systems we were working with. We had to know the feedstock and understand how this process was going to be captured and processed. The materials we were working with were cellulose and polyester, which represent about 90% of the textile industry. So that was a really sort of useful starter. And the people involved in the projects were textile companies, but also reinforced plastic for the automotive industry and plastic fibres for sort of novel and performance garments. So we ended up with this kind of trace through lots of different choices in a way through the project to try and keep everyone on the same page. And then again, the same postdoc, who's a textile designer, this is not her usual way of working, started to map the decisions and the development of the design concept. So if you imagine you've got 19 partners from different parts of the process all together trying to bring sense and form to a design concept, it gets very complicated. And I think at its widest point, this was about 31 different concepts. We've now narrowed it down to 6, but the whole thing had to be a democratic process. Every decision made along the way needed input from everyone in order to make sense of it. And I think this will be probably one of the key outputs of the project in understanding how to shortcut this, perhaps. And then along the way, as we're developing these concepts, we had to find new ways to work together. And in order to understand circularity, one of the most useful tools we found was just getting everyone literally around the life cycle in a physical space. So we ran a few workshops with variations on this, where we got the concepts and we talked about the journey of those products and those concepts in sort of multidisciplinary groups. And what was fascinating was over the course of doing this through several concepts, the same kind of limitations would come up from the scientists, or the same challenges from the designers, and we sort of come to some kind of shared understanding. And also around the table there was a space to discuss points of contradiction, or where the language didn't quite fit. I can't tell you how many times we would be talking about something and we'd think we'd be talking about the same thing and it was different. I mean, even a scientist's understanding of what paper is totally different to what we think of as paper, or lots of parts of the process. I mean, never mind recycling, regenerating, recapturing, recovering. All of these words mean something very different to different people. So one of the things we're building up from this project as well is a glossary of terms, of shared understanding. And this all feels like a very lengthy way to design a product, but it's really much more about the learning along the way. And what we realized, so, you know, as designers, we're now developing tools, we're facilitating conversations, we're trying to be, I suppose, the Jill of all trades, the overview, but connecting in the real experts in the field who can stop us sort of falling into these generalizations that are very easy to trip up over when we're trying to design sustainability. And in the life cycle modelling phase, we conducted a sort of review of the tools that were currently available. And when we analysed them in a sort of quantitative to qualitative spectrum, so, you know, things that were very data-driven, things that were perhaps more creative-based, and then a pre-production to post-production, so tools that are used to audit designs and tell you if they're effective after they've been made versus something that can help you to design in the first place. We realised there were a lot of data-driven end of pipe measurement tools, so LCA, you know, very technical data that will tell you this product will improve impacts in this way. There were also quite a few that were good at storytelling, that were good at communicating those facts back to the designer, which are extremely useful. I mean, things like, there was an RSA project called Changing Habits quite a few years ago now, that you typed in your lifestyle choices and it would show you a picture of yourself with body parts enlarged depending on where your impacts were. So if you were very heavy on transport, your feet would grow. I mean, a really kind of visual exploration of data. And there were also lots of tools, and we've been responsible for some of them, the RSA, Puma, sort of tools that were about conversation starters, idea generation. You know, one of the tools, the 10, which was one of the first projects we did as a research centre, is very much about sort of almost like a card game. How do we bring in layers of sustainability thinking? So you might start with something that's just about reducing chemicals or impacts, but how do we activate that? How do we bring in other issues on top? But there was virtually nothing in what I call at this stage data-driven design. You know, tools that we could bring the insight from this into the design process. So that's what we've been trying to do in our current projects and in Trash to Cash. And I suppose this is the iteration of those tools. We started from a very basic life cycle conversation with the scientists back in sort of workshop 5 a couple of years ago in Copenhagen, and then at every workshop since we've developed those tools into something really quite complex at the moment, where all the insights from the different stakeholders have been captured, represented, and then they get refined with every workshop. And we're really starting to get to a place where we feel the design process can be pushed forward. In our other project, we're quite taking a different role, really. In this project, we have control over the design process. We are the designers. In Trash to Cash, we feel like we're almost doing everything but the designing, because it's much more a facilitation, a bringing together role. But in the Mistra Future Fashion project, we are trying to design concepts based on the collaborative work that's going on in the project. And at the end of phase 1, there was an exhibition, a collection of designs which all explored recycling, design for recycling in some way. And what we realized at this point was that there was a spectrum, as there always is, of approaches which spanned from what we call product longevity. So how do you design products that can last longer, be cherished for longer, perhaps be upcycled or turned into multiple products. But also at the other end, there were some projects that were really nothing to do with product longevity. They were about sort of new production processes, efficient production that could be chemically recycled at the end of life. So although the product lifetimes might be short, the materials could be reclaimed. And we could see there was value in both. So the work we're doing at the moment is really trying to understand how these sort of two approaches might differ, and if there is potential for, I almost hesitate to use the word, but fast fashion to be good. You know, if we accept that part of the market might need to be, continue to be fast or shorter life at the very least, how can we just do that differently rather than always trying to be saying that this is the only way forward? I think one of the most interesting things we found through the sort of the social science studies in the project is that any sort of one person will have all of these approaches in their wardrobe. You know, you might have a piece you've saved from a gift from a family friend. You might be part of the sharing economy. You might have something that you wear till it falls on the ground in tatters. But you're also going to have some fast products as well. And actually, sometimes we don't understand the difference. When I'm at sustainability conferences, often, you know, this is challenged. And I say, but one of my longest lasting products is an H&M polyester shell top. Explain that one to me. It's not been designed with that in mind, but we're trying to understand where those differences occur. And then finally, thinking about changing the system. None of this works, as I said before, in a sort of a theory vacuum. And one of the most exciting parts of the Mistra Future Fashion work is our opportunity to test this with a company called Filippa K, based in Sweden. And they work with sustainability at a very high level, and they have a project called Front Runners, where every 2 years they take one item in their collection and they redesign it in a multidisciplinary way. So they bring in stakeholders from all over their company, including the raw materials suppliers, the production team, the marketing team, really, really important to have them there to understand the user, and also even the retail, people from the shop floor, together to redesign a product to the utmost standards as a blueprint for then feeding back into their collection in following years. And this was a sort of a perfect setup for us to go in and test some of these new tools. So we've been working with them since last March in a series of workshops looking at fast and slow. And initially the idea of fast was a very, very difficult one for a sustainability company to think about. But actually, in working through the design process in this way with everyone in their system, there are some really interesting results starting to come out. It won't be launched properly until November, but there will be both a fast and a slow product as part of this collection. And I suppose one of the things that we find ourselves doing a lot is translating some of these concepts or ideas into sort of tools based on metaphors, so that we can test them not only with industry but also with students. So my colleague Becky Early is brilliant at this and designed a set of tools for use with some sort of SME, small young fashion companies, for them to understand the speeds within their collections. And so it was all based on the idea of a speedometer with a series of exercises where you either sped up or slowed down your designs, and how do you really do that? You know, what are the design decisions you're making? and how can you affect it. So I think those kind of tools are also really important, as well as the translation of the scientific material. It stops there unless you can then communicate it effectively forward. Doing for time. So, so one of the projects that we're sort of responding, or the way we're responding to the fast fashion story in Mistra is something that started in phase 1 and has really taken on a life of its own, which is how can we design short life fashion products out of a new material that is lighter in production, lighter in use, and fully recoverable. And to do that, we started with a hunch, as you often do with design. We started with the idea, okay, paper clothing, it's existed before, not particularly successfully, but because the partners in Sweden have a fantastic papermaking industry. I mean, their main material is wood, cellulose, and this industry is in decline, and there are these enormous papermaking facilities with downtime. So we started looking at, could we develop a paper that was an effective textile that didn't need laundering, that you wore, it was designed to wear a handful of times and then be disposed of, but that disposal route would be really, really clear. And to do that, we needed to collaborate with all the other parts of the project. This isn't a new idea. In the Second World War in Sweden, in the Alstrom paper factory, they turned all their manufacturing over to the making of clothes, because obviously in a time when needs had changed. So there's a sort of a historical trail here, which is a really, really interesting background. But when we were working through with the scientists on this project to get, or the environmental scientists, to get an understanding of whether this really would make the improvements we believed it would, the part of their project was looking at impacts based on production, and one big insight was that fabric production, I don't know if you can see on this, which is here, is by far the biggest impact in terms of water and energy. So they were saying actually just by switching to a non-woven material you make huge, huge savings. But obviously non-wovens are not, they don't behave in the same way as woven materials. So all of a sudden our challenge is, how do you get stretch into a non-woven? How do you get drape? How does it feel like cashmere, which was the brief we gave the material scientists. But the really exciting thing was we were able to build this material from, actually I'll go back to this one, from scratch. So we made a material designed for this paper machine based on cellulose and PLA, which is a cornstarch. And because of that, we could use a lot of different processes with it, heat processes. It has a thermoplastic quality. So we could all of a sudden micro-pleat it to give it stretch. We could heat it to give it stability so that we could dye it with natural dyes. You can't dye, you can't usually dye paper in this way. It just falls apart in the water bath. We also have looked at biofinishes, biowaxes, enzyme colours. It sort of set off a whole project around how we get effects, decoration, function into this material for it to be a plausible, wearable fabric. And then in doing that, what does that system look like? You know, how would it be recycled? So they're doing tests on the material for compostability, which are due to finish this year. The initial results look good. And also recycling as paper. You know, what if you could have a garment that you could just throw out with your newspaper and it would be recycled in the same way? We don't want to be setting up new systems for niche products. It kind of needs to fit with the existing system. And then how might the production model change? You know, if you could digitally manufacture these products, but also link them to local recycling hubs, you've then got a system that's much more local and sort of flexible, so translatable. So the idea is you could make these paper garments and then recycle them at end of life. But also, because we're looking at the spectrum, as well as the paper, we're looking at the polyester non-wovens, which takes us back to some of the laser finishing. So, you know, how would this system work a little bit closer to what we have now? Could the same kind of redistributed models work for producing clothing that's much closer to what we know and understand. And then also, we're finding that some of these processes are really useful for the long life stories. So, you know, refinishing old garments using the same technology means perhaps we will have the whole spectrum in the same approach. But I think one of the most important parts of this process has been, and for both projects, is about bringing the other parts of the chain into the design process and letting them guide it. Us not sort of just having an idea of what it should be, but having the conversations as part of the design process. So the scientists from RISE Sweden literally have been with us since day one on the brief to try and understand. And one of the most complicated things was the language to describe what we needed. You know, the idea again of drape and stretch and different qualities. Softness means something completely different to them. So the way we did it was to bring in this piece of cashmere and say, right, it needs to behave like this, it needs to stretch, it needs to drape, it needs to... and then how we change the recipe of the fibre in order to find the perfect balance between the two. So this project, again, is due to end at the end of this year. We've got a piece in the V&A exhibition coming up in April, the first paper garment, but the full project will finish at the end of this year. This is almost the last slide. And just really this idea of design, I suppose, getting involved in these new areas, kind of design activism. We've been very involved in all these companies that are really the game changers in terms of recycling materials. It's not available yet, this chemical virgin quality recycling, but we're working with companies through projects and also through involvement with their business development on how close can we get this technology to market, because once these problems are solved, it will completely change the design space on a massive scale, and we see them as working together. So everything from companies like Worn Again, who can recycle for the first time blends, pull out the polyester, pull out the cellulose, and use both streams as a viable virgin product. And then others working in the area of cellulosics, others working in the area of pure polyester. So together they'll make up a massive resource efficiency. And as designers, we need to know about this, and we need to be involved in understanding the process in order to find where those challenges might be in the system. So just to round up, going back to those three aims, I suppose, for circular design: understanding the system, redesigning the system, and changing the system. We think that the ways we've been, our work has been changing is moving from a traditional design process into, I think, some of these things that we're seeing. I think there's going to be lots of crossovers between our talks, but designers as translators and communicators, designers in the lab is a sort of shortcut for this real interdisciplinary process. You know, how do we craft science and have conversations at that level? Designers as facilitators and sort of enablers of co-design. How do we bring groups of people together and find productive ways to work and move forward? And designers as activists and change makers. How do we get into industry and society and find tipping points and make change happen on a really systemic scale? Because I think if we show the right way to, if we show users something that is better, it can happen overnight, the change. But it's not going to happen through sort of guilt or making them feel bad. So I think these really are starting points more than anything. It's something we've observed through our own experience and practice over the years, but I think, as I think Jan had yesterday, there's a huge amount of literature and wealth of knowledge in this area that can help us now to redefine the next set of practice-based exploration. And I just wanted to end on this idea of sort of moving beyond design thinking to a much more sort of systems design approach, and how design really needs to be a creative act, looking at how we can change behaviour patterns and how we can change process patterns as well. And I love the idea that we might have the power to dissolve problems, not just solve them. You know, how can we change the system so that some of these problems we're trying to solve actually are irrelevant and no longer a consideration? And that's a very, very exciting thought for the future. Thank you. That's my last slide.